So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a quick topic test with a collection of Gcse exam style questions on volume at foundation level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much or understanding you have on this topic. Now, like with many of these tests, there is no indication about whether these questions are specific to a non-calculator or a calculator paper. So what we'll make sure that we do is we show our full working out and show the calculations that we're doing. And if we need to work them out manually or using a calculator, it's not going to be a problem. So let's have a look at question 1. So question 1 says, which of the following is not a measure of volume? And so we've got litre, cubic centimetre, metre and millimetre cubed. And the one that you want to highlight is meter, as that's the one, not a measure of volume, but volume can basically be the number of cubes inside a shape, but also the capacity as well. So that's where litre comes into question. But also 1 litre is also equivalent to 1000 centimetre cubed. So they both go into each other. Looking at question 2, it says here is a cube and a cuboid, and it says which has a greater volume. So if we start and it says when you show our full working out, so for this we've got the cube. You can either write a cube or you can label it as A, it's not really a problem. So we've got 5 times 5 times 5, which is 5 cubed, which is 125 centimetre cubed. Also, it's worth making sure that the units of each of the lengths on both shapes are the same. Then moving on to the cuboid. So here we just need to multiply the length by the width by the height. So we've got 5.5 multiplied by 6.5 multiplied by 3.5. And I think the reason why they've chosen whole numbers and decimals is purely to prevent people from guessing. So here we've got 5.5 multiplied by 6.5 multiplied by 3.5, and that comes up to 125.125 centimetre cubed. And I'd say you would probably expect to do that on a calculator. So looking at the two volumes, we can see which one of those is greater. It's going to be the cuboid. So moving on to question 3, it says that a cylinder has a radius of 4 centimeters and a height of 6 centimeters. Work out the volume, give your answer in terms of pi. So again, this question could easily appear on a non-calculator question because they've asked us to give our answer in terms of pi. So looking at the volume of a cylinder, well, the volume is pi times r squared times h. So all I need to do is substitute these two values where r equals 4 and h equals 6. So the volume is going to be pi multiplied by 4 squared multiplied by 6. So v equals pi times 16 times 6, and 16 times 6 is going to give me an answer of 96. So the answer then is 96 pi. Moving on to question 4, it says here is a triangular prism. Work out the volume. Well, to work out the volume of any prism, all we need to do is to work out the cross-sectional area, which is the triangle, and multiply that by the length. So here we've got 3 times 5 divided by 2, which is 15 over 2, and then we multiply that by 8. Now 15 over 2 is 7.5, but if it was non-calculator, I would leave it as this. So you're either going to do 7.5 times 8, or you're going to do 15 multiplied by 8 or divided by 2. And either of those that you do, you should end up with an answer of 60. Then moving on to question 5. Now just to go back on question 4, always make sure that you are showing that you're working out the area of the triangle, or it's evident which part of your working out is the area of the triangle. Then multiply it by 8 because you want to show that times 8, and then that will give you the answer of 60. Moving on to question 5, it says these two cuboids are similar in shape. How many small cuboids will fill the large cuboid? Now, so what we need to do first is the fact that they are similar shapes. So we need to fill out the missing dimensions. Now here we've got 2 missing dimensions. On the smaller one, I don't know what the height is. And on the larger one, I don't know what the width or the depth is going to be. So I need to work out those first. So first of all, I need to know what the scale factor is. So if I pick the two corresponding sides that I do know, So the scale factor is going to be 8/2, which is 4. So it basically means that this larger cuboid is 4 times the size of the smaller one. And then to go in the opposite direction, I need to divide by 4. So for here, I can now work out what the missing lengths are. So if this side here is 3.6, I'm going to divide that by 4, and that becomes 0.9. And then to work out what this green length here is, I look at 1.2, I multiply that by 4, and I get 4.8. So from this, what I then need to do then is work out each of those. Now, from this, all I then need to do is just either divide how many go into which. So how many 2's go into 8? Well, that's going to be 4. How many 1.2's go into 4.8? That's going to be 4. And how many 0.9's go into 3.6, which is going to be 4. So it's going to be 4 cubed, which is 64. And from those, and again, you could have easily done it by knowing your scale factors. So if you've ever studied similar area and volume, if the length scale factor is 4, it means that the area scale factor is going to be 4 squared, which is 16. And it therefore means that the volume scale factor is going to be 4 cubed, which is 64. And you could have got the answer going that way as well. Then moving on to question 5b, it says which information given on the diagram is not necessary to answer part A? Well, then using the knowledge of similar area and similar volume, you could basically say something along the lines of that only 2 corresponding sides or comparable sides lengths are needed to find the scale factor. And you could say as long as the length scale factor is, let's say, 4, then that means the area scale factor will be 4 squared and the volume scale factor would be 4 cubed, and you could get the answer that way as well. Moving on to question 6, it says here is a cuboid. The area on the top and the 2 sides are shown. Work out the volume of the cuboid. Now these questions are very, very similar, and you need to recognize that here we've got 3 lengths that we need to work out. So we need to work out what this length here is. We need to work out what this length here is. And we also need to work out what this length here is to work out the volume of the cuboid. Now, what you want to do with this is basically, if I look at this side here, now what part of the rectangle is that blue line connected to? Well, it's connected to this 15 and the 21. So you want to think of a common factor of 15 and 21. And what number goes into 15 and 21? Well, that's going to be 3. For the next one, we've got this green line. Well, that green side connects to the 15 and the 35. So you then want to think of a common factor that goes into both 15 and 35, and that is going to be 5. And then for this blue line, it's a case of what's a common factor between 35 and 21? Well, that's going to be 7. So there I've now got the 3 lengths of the sides of the cuboid. So then the volume is going to be 3 times 5 times 7, which is 3 times 35, which gives me an answer of 105. Then moving on to our last question, it says here is a sphere, and we've got the formula for the volume of a sphere. It says the volume of the sphere is 36 pi centimeter cubed. Work out the value of r. So what we need to do is make this formula equal to this. So here I've got 4/3, and we've got p, and then we've got r cubed equals, now I'm reckoning that p shouldn't be there, and that's basically representing pi. So let me just get rid of that and swap that for pi. If it's come out on your printout or on your screen, it should be a pi there, and that's equal to 36. Let's put the pi in the same color. So from this, what we can then do is, well, both sides have got pi, so I can cancel that out. And so what I've got needing this side is 4r cubed divided by 3 equals 36. So what I've got to do first is try and get r the subject. So I take the 3 over to the side by multiplying by 3. So I end up with 36 times 3, which is 108. So I've got 4r cubed equals 108. I've then got to divide by 4. So 108 divided by 4 is 27. So r cubed equals 27. And what cube number gives you 27? Well, that's going to be 3. So our final answer then is going to be 3, and the units are in centimetres.